is now the policy is that we have to take attendance. So if the way we can do that is for everybody to let me back up just a little bit. This course is going to use Blackboard. Who's used Blackboard before? Everybody down there use Blackboard? Yes? Okay. I've never used Blackboard before. So we're going to use Blackboard. And the way that we're going to use Blackboard is that I'm going to put all the course materials up on Blackboard. And there's also a what do you call it? A discussions forum. And rather than actually taking attendance, what I'll do is everybody will be responsible for doing the homework assignment, and there is a homework assignment today. And if you don't do the homework assignment, then you won't be counted as present. So you need to do that in order to be counted as present today, and that'll be reported to USM because that's the new policy. All right, so I'm going to share the screen. I'm going to show you what it looks like in Blackboard. All right, so rather than looking there, I'll just open up a new. So you go to Blackboard. Sounds like everybody's done it except for me. Sorry, it's usm.blackboard.com. usm.blackboard.com, and you have to log in using your USM username and password, which is that going to be a problem for anybody? Everybody can use Blackboard? So anybody here that has a problem with that? Okay, good. All right, so then you'll go down to courses, and I don't have the entire course built because, like I said, this is my first time using Blackboard. It's annoying. But I have different courses than you, but the course that we all share in common is this one called GHY 469, 569 Web Map. So if you can, get on there and use that. Now, you'll notice that there's one for web mapping and one for web mapping lab. The way that I'm thinking right now is that we don't really need two different Blackboards, because everybody is enrolled in both courses with one exception, but they're only enrolled in the lecture. So I'll put all the materials on the lecture Blackboard because then everybody will get them. So both the lecture and the lab materials will be on this Blackboard location. Okay? So there's only one Blackboard location, even though you're technically enrolled in two courses, a lecture and a lab course. Does that make sense? So click into that course, and you'll see the information. We all know that the course meets Tuesdays and Thursdays at 1 p.m. Does anybody know how many hours this course is? It's a total of 4 hours, but technically it's a 2-hour course with a 2-hour lab, right? So I don't know why they put it in the schedule the way it is, but we have 8 hours a week listed in the schedule, but it's a 4-hour course. See what I'm saying? Because technically in the schedule it says we're meeting from 1 to 3:30, so they doubled the amount of time that we actually need to meet for this course. So we actually don't need to meet from 1 to 4, or 1 to, I forgot exactly what the time is, but the point is that we don't need to meet nearly as long as what's in there. Because technically for a 4-hour course, you meet 4 hours a week, or 4 50-minute periods a week. And so I put here that our lecture meeting will be Tuesdays and Thursdays. It'll start at 1 p.m. and it'll last probably about an hour because it's a 2-hour. The lecture portion of the course is a 2-hour course, and so we'll teach that twice a week, once on Tuesdays, once on Thursdays for about an hour. Okay, so that's the way the course is designed. And then we'll have our lab immediately following the lecture. Now, labs actually often do need a little more than the hour that they're allocated. But the activity portion of the lab is supposed to take about an hour, and then you have an hour where I can help you be there, or whoever the lab teacher is. In my case, it's me on the coast. We're working with that. We have somebody in mind. I'm going to meet on Tuesday and talk through that a little bit more. But I will probably make trips down to the coast, and so we'll have some periods where I'm broadcasting up from the coast. Somewhere it's the reverse. But in either case, I'll record what I did for the lab on the computer. You'll have that. You'll have the discussion boards, this is a web mapping course. The idea is, someday it could be done as more of an online course anyway. All right. Okay, so your instructor is me, George Raber. I know lots of you have had me before. I've been here 10, 11 years at USM. I enjoy doing this. I mean, I enjoy GIS, and so hopefully we'll be able to pass something that's exciting to me along to you. All right. Here's my email. My phone number. Is that my phone number for the office, or is that the department office? I always forget which one's which. Nobody ever calls the department office. One of them is 4729, and one of them is 5807. Forget which one that is, because sometimes I get people to the department office, and Anyway, I can also put up my cell phone number, but I'll be around every Tuesday and Thursday. I teach on Tuesdays and Thursdays, and so I can guarantee that with the exception of maybe 1 week of travel during the semester, but I'll be around on Tuesdays and Thursdays for you to ask questions, and I'll most likely be around every other day. But sometimes I'll use those days for field work or meetings or whatnot. And so if you can't meet at this time for office hours, just let me know. What's my office?
That number.
226.
No. 5807.
Oh, okay. That is my office phone number. Okay. 227. It's probably a lot easier to get a hold of me by email anyway, but in any case, if you want to come by and talk to me, even if it's this time period, it's probably best to send an email first. Although this time period, I'm almost for sure in my office. My office is right on the other side of the hall, right before you make the turn to go down the stairs. Okay. All right. Okay. So with web mapping, I think that's all pretty good. Most of the links that I'm going to put for the course are here under course materials. Okay. Under course materials. So let's try that out. If you go under course materials here, you'll see the course materials for week 1 are already there. If you click into this, if you click into course materials, this one right here, if you click into that, then you'll see I've attached a reading and I've attached an assignment. This reading, I actually modified a bit, but I did draw heavily from another course that deals with this material. So this is the reading. What I'm trying to say is it's not published in a book or anything. Sometimes the readings will be from selected readings from books or from chapters. This I draw it heavily from other online material. And then we have an assignment right there, and we'll go through the material that's in the reading. I'll talk about it, I'll lecture on it today, and then we will we'll talk about the assignment. And the assignment is the thing that you need to do in order to make sure that you count it as present for today. All right. Okay. So, but before we do that, I do want to just quickly, because it's the first day of class, go through the expectations, the syllabus and stuff. That's under this link called syllabus. So if you click on that, you can pull up the syllabus. It'll download. It should download into it's a file called WM2. It's the second time I've taught this web mapping course. So I called the file WM2. I don't know why I didn't really need to explain that, I guess. Okay, that's all the same material. Here, yeah, I can let you read this entire thing on your own, but the important thing here is that we are going to talk about web mapping, and this is an introductory web mapping course. It doesn't, the course itself doesn't assume that you have a lot of web development skills or any web development skills, but we are going to get into using some web development skills towards the middle of the course. Okay, we're gonna start off talking a little bit about the history, the importance of this process, and then we're gonna talk about creating web services, which that in and of itself doesn't always involve a lot of programming, but does a little bit. And so we'll get into that, and then we're gonna talk about making some of our own web maps using kind of like interactive tools, but also get into utilizing a little bit of programming. Okay, so you need to. This is a GIS course, so I probably shouldn't have to say this, but you can't really be afraid of computers, and you have to be able to get in there and do some computing. In this case, some introductory level of programming. It probably would have helped, and we do list this as a prerequisite, if you've taken some introductory level programming course before taking this course. But that's not a strict prerequisite if you feel like you can do that. Okay, so to read that, here I've got 2 bullets here. I want you to have enough experience coming in with HTML. HTML stands for Hypertext Markup Language. It's basically the format that web pages are created in. To kind of read through an raw HTML page, see where the heading is, where the script tags are, and so forth. If you don't have that, you can get that actually by just doing this tutorial. So I recommend you follow through that tutorial. And some of this information will be provided, but this isn't a course in HTML, but we will provide some of that information. But it would be very helpful if you're not coming from that sort of background to follow this through. It might take you a couple days to do it. We're not going to get to this portion of the course until later on, so do this early. Okay, and then the same here, where I say. Actually, while you're at it, you can do the same thing for JavaScript. JavaScript is the language, the computer language that allows you to make your web pages dynamic. So when somebody presses a button, something changes. When somebody clicks a checkbox, a map layer turns on. It's JavaScript. It's a programming language that will allow you to do that. Okay. So that's what that is. So consider that your first homework assignment. This isn't the homework assignment I'm talking about. This is not something that has to be turned in. But if you don't come from a background where you're comfortable with that, do that. So do that first, then do this. So we won't get into using that knowledge for a few weeks. So you have a little while to do that. Okay. All right. So this is the tentative schedule. I won't go over everything either, but notice that typically I've set 2 dates. Occasionally during the semester, like this week, we didn't meet on Tuesday because the semester hadn't started. So you'll notice that we have another date on the 20th, and I believe that October 20th, so in 2 months from today, we have another date where we don't meet on Thursday because of fall break, and we don't meet on Thursday here because of Thanksgiving, but other than that, that's what we're going to talk about. So today it's going to be an introduction to what we're going to talk about for the rest of the course, and then we get into actually doing things. We're going to build some services, some maps, some web map services in the first few weeks, which you may be like, what do you mean by that right now? But that's what we're gonna. By the end of today, you'll know what we're gonna build, hopefully, and then later we're gonna like actually utilize them and create web maps, and then talk about a few other things during the rest of the semester. Okay. All right. So, like I said, everything is available on Blackboard. Unless otherwise noted, I want you to turn your assignments in to ghy.gis@gmail.com. Today is one of those days that's different. Today, you're actually going to post something on the Blackboard discussion forum. I'll cover that before we get out of class today. Okay. Today, what will probably happen is that, it's already 11:26. We'll probably end up talking for another 30, 40 minutes today. And then, so we're going to go into the lab period a little bit, but there's really no lab to do today. Today, you're basically, today's assignment is to watch a video and respond to the video. So we'll get out of here as soon as we're done talking about today's content and the assignment. All right. There won't be a formal assignment, a formal textbook for this course. There will be readings, and I'll provide those readings on Blackboard. Almost always they'll be uploaded to Blackboard. Okay. I already covered the course structure, the lecture lab. Here's a breakdown of the grading. The only difference, everybody's responsible for a final project, undergraduates and graduate students. The graduate students, though, will have to present their final projects. So that's a slight difference in those two. All right. So these are a breakdown of how your grade's determined. If you have any questions, you can ask them or come after me. Come talk to me later or ask them on the discussions. It's really helpful if you do have questions about any homework assignment or anything, if you post them in the discussion forums, because then they'll be answered there for other people to look at. You can go search the discussion forums. There's your lab grade. The rest of this is all just standard stuff that gets included on all syllabi, whatever. Okay. Let's see. I got how many? I can't see real well because of the darkness. How many people do I have on the coast down there?
There's 3 enrolled, but one's not here today. I'm actually Heather.
Oh, you're there. Okay, great. Are you enrolled in the class?
No, I'm not. I'm just here.
Okay. All right, thanks. Yeah, so you wanted to talk after Tuesday, that's fine. So there's 3 people besides you in the class?
Well, there's 3 people enrolled according to SOAR.
Okay.
But only 2 are here.
Okay, 3 people according to SOAR, but 2 are there. Well, if you know that person, or I can send them an email, and if they complete the assignment, then they can be counted as here. USM wants to know who's actively participating in the course before the drop deadline. So that's what they want to know. Okay, so you said there's 3, there's 2 there, and here I have 1, 2, 3, 4, 5, 6, 7, 8. 8. Okay. Write that down. Actually, that's recorded on video, so I can go back. 8 up here, 2 down there. So I should be expecting 10 or 11. I should be expecting 10 or 11 assignments from today. Okay, great. All right, let's get on to talk about what we're going to talk about today. Now, I'm not really big into using PowerPoint, although I probably will use it sometimes. But what I like to do is to speak from my notes and then actually show examples on the screen. Today, I couldn't print downstairs to the downstairs printer, so I don't have my notes printed or on a different computer. But I do have them, along with everybody else. I have them right here under reading. So I'll go from that and speak from the reading, and then probably show other things on the web page. Okay, and so like I said, today we're going to cover 3 or 4 topics. One of those topics is just going to be an introduction to why we're having this topic. Okay, the history of web mapping and why it's important. And a lot of you probably realize that it's important already, but we'll talk about a little bit, and we'll start to get into what's actually going on in the background. But then we'll leave a lot of that to next week. We'll start talking about that. Then we move on from that topic. We talk a little bit about the 2 different types of software models, really, that are out there in the general world. But this applies a lot to web mapping. Web mapping is in the GIS field. That segment, what we call web mapping, in the GIS field, has the most kind of crossover between the open source world and the commercial world, and then kind of like the packages of software that are in between. Like they're free to use, but they're not really open source, kind of like Google services. And even ESRI. So everybody knows when I talk about it, I say ESRI. ESRI is a company that creates Arc Map. It's what we usually teach in these software packages, in these classes. Arc Map is a commercial or proprietary software package, and there are also alternatives to Arc Map that exist out there in what we call the free or open source market. So we'll talk a little bit about that, because web mapping presents some unique opportunities in that part for a variety of reasons. One is that server software in the commercial world is very, very expensive. And so there's especially for people starting out, there's much less barrier to entry in the free and open source software realm. And so that's one of the advantages. We'll talk about all that as we get, that's the second thing. We'll talk about commercial software, and then we'll end it for today. Okay, so when I first started out in the GIS world, the internet was brand new. I mean, this was like 1994. Okay, and the extent of internet mapping was to put a map, an image on the internet. Okay, it wasn't interactive yet at all, but that quickly changed. Okay, one of the first experiences, or the first people to experiment with this was actually my undergraduate advisor here, Brandon Flew. Okay, he wrote a software program that ran on computers that actually took Tiger data. Anybody know what I mean when I say Tiger data? Tiger data is the census lines. The census lines, and if you ask his program for a particular bounding box and which layers of the tiger you want it turned on, it would return back an image. Okay, so his program did that. So you could say, hey, I want to see this rectangle of the world. Okay, give me this rectangle, and it would go in, and basically it would do the equivalent of like having your own little personal GIS analyst open up at the time. The only GUI interface GIS software was called ArcView. It would open up ArcView and turn on the layers that you wanted, zoom into that location that they had specified, and then press export to image. It would save it as an image and then give that back to you. That's what his program did. Okay, and he wasn't the only one that was doing these sorts of things. ESRI quickly developed a software package called Arc IMS. It stands for Arc Internet Map Server. And fundamentally, these programs are as simple as I just described. They take geographic data, they symbolize it according to some input commands, and produce a map, what we call a map, okay? And so it wasn't hard to turn this into a web mapping application. And that's exactly what ESRI did when they created Internet Map Server. And so the fundamental aspects of an Internet Map Server have not changed. That's still what they do. Okay, they sit there. They're a program. They're a computer program running on a computer. The computer program running on a computer is a silly thing to say, but they're a computer program that is running, that's waiting for you to send it a bounding box, what layers you want to turn in, and eventually there's more and more options. You know, what colors you want them to show up, different things like that. Okay, they started out exactly as I described, and you can still actually create an internet mapping program that does that. It's called a dynamically drawn web map. Okay, and a dynamically drawn web map is a web map that is a computer program that's waiting for inputs. It runs, it creates a map, and it creates that map in some format that a website can use. So it has to be a JPEG. What are some other PNG, a GIF? Yeah, it has to be one of those formats. Okay. All right. Now, this next paragraph is saying that eventually, and this is still the case, dynamically drawing web maps don't scale very well. Okay? You have lots of people requesting maps. You need to have more and more computing power to make them work. Sometimes there's no way around this. If people want the colors to change based on some input parameter, or if people want to symbolize it differently, or if people want to see something different every time they go to the web page, there's no way to get around a dynamically drawn web map. However, what some people eventually realized was that they could separate the content that they wanted dynamically drawn from the content that didn't need to be dynamically drawn. What's another word that we might use for that on a map? The content that doesn't change static. Sometimes we might use the word base map. Okay, so Google Maps was really the first company to grab hold of this idea. So Google Maps, they created websites that had pre-made maps on the server. So if you said, hey, I want to see this area of the world, Google Maps pulls up that image. Okay, it pulls up the image for that area of the world, and they're already made. So the server is actually not doing any work except for pulling up the map. And this allowed for maps to start getting slippery. I'll show you. You know what I mean once you see this. But if I go to maps.google.com, and I can do this. It took a little second there. I can do that. Okay, that happened sometime late 90s, early 2000s, and probably early 2000s, where maps started to be able to do. Before that, you had to the map would pull up, and there was usually be an arrow here, an arrow here, an arrow here, and an arrow here. And you pressed the map. You pressed that arrow, and when you pressed that arrow, what it was doing is sending a request to the server for the map that was right next to it. Okay, and so now we're actually going to use this later, but let's look here. If you go under the JavaScript console and you hit network, you can see that when I move it around here, I'm getting more information here. And if I right click on this and if I open this link in a new tab, Google has some. Let's do this later. For Google has some. It's trying to make it so that you can only use their tiles inside of their maps. Okay, so, but not every site is like that. All right, so that's called a tiled map. So most web maps that you actually experience today, like the one I just showed you, have at least a tiled base map in the background. Not every single one. Some still are totally dynamic, but it's much more efficient to separate your map services out like that. Okay? You've got your tiled maps, your dynamic maps. Your tiled maps are pre-drawn. One of the things that's done to the, I don't think I mentioned this in the reading here. One of the things that's done is, yeah, okay, so, well, I kind of implied it right here. One of the things that's done is kind of standardized the world map, okay? The world map that's seen on the web. So if you're going to use any of these pre-existing base maps, like I mentioned them in the reading here, Google has their version, Microsoft has their version, Yahoo has their version, and I left out the big GIS thing in the room, is ESRI has their version, okay? Is that it's created a single map because of a single map projection that's used worldwide. See this map here. If we want to lay other data on top of this map, our data needs to be in the same projection. Okay, so this is the one that Google chose, and so it's become the most widely adopted because they were the first ones at the table. It's sometimes it's called Web Mercator. So it's a Mercator projection. It has some weaknesses. One being that it assumes a perfectly round world. It's a spherical Mercator. So taking measurements off of it isn't the best idea. We'll get to that later down later down in the course. But that's the projection that they use. Another one of the things that it's kind of forced on web mappers that web mappers often struggle with, especially if they're trained in the art of cartography, is that it doesn't always allow for the best cartography to use somebody else's base map with your data, okay? Because you've got, you're taking your symbols and you're putting them above any symbols that appear on the base map, including labeling cities and streets and things like that. And so there's now a proliferation of different base maps that are available to try to overcome this need. Okay? But it's often, especially depending on your size or area, it's often good to make up your own base maps. Then you can do your own area. All right. Okay. So web browsers have become more and more quick. You know, around the time that Google Maps was first created, Gmail was first created, and I don't know if anybody had. I'm starting to get old, I guess, but if you had a webmail account before that, I never wanted to use it. It was really frustrating. Every time you clicked on a new email to read, the whole page would reload. Okay, so one of the neat technologies that has come out that's actually mentioned above this is what we call AJAX, or asynchronous requests. So a single web page can make requests to multiple different web pages and show data for those multiple different, or I shouldn't say web pages, multiple different places on the internet, and show the data from all those different places on the same web page. So I can, for example, when I go to Google Maps here, okay, although I'm at www.google.com/maps, the images are being loaded from other locations. Okay. Some of the other cool things that came along recently, or in the recent past, are the ability to put things like pop-up windows, to basically draw things on top of maps that are complicated, including nowadays even drawing features right on the web browser. What do I mean by features? Points, lines, and polygons right on the web browser. Okay. All right. sometimes we call lots of these new web technologies, we refer to them as HTML5. Okay? Yeah, and now we're starting to even get into the mobile area. All right, now I've alluded to this concept before. I'm going to just skip down because we'll talk about this. I've just discussed this, but let's make sure that we understand what's going on here. Okay. So when we're talking about internet mapping, we're talking about making a website that has an interactive map on it. Okay, and these are the components of an interactive mapping web page. Okay, these are the hardware components. We have a server, and that server is what's running that little program that that began back in the late 90s that is waiting for a request, and that program is waiting for a request, and it's going to draw a map based on that request. This is an example of what a request. This right here is an example of what a request might look like. Okay. Depending on the program, the request is gonna look different. Different programs accept different requests. Okay? However, there was an effort to standardize the requests, and that's where we're going to get in talking about free and open source software and open standards versus ESRI, who decided to adopt the standard, but then also decided they were going to have their own method for making requests. Okay, so this is a request that might get sent. The client is the computer you're sitting in front of. Okay, that client could be a desktop, or in today's world, that client could be a mobile phone or a tablet or whatever. That's the computer that gets interacted with. The server is shown without a screen because to the end user, it doesn't matter if there is a screen. In fact, sometimes there isn't a screen. So the client makes requests to the server responds to those requests and sends some information. So this might be the map that got sent from this web request. Okay. I'm going to hit that. So this is an example. I'm going to hit this control click. This is a PNG of some weather data. Okay, so this is a map, and this map isn't meant to be looked at by itself. It's meant to be draped over an existing base map. Okay, but you could see probably the darker areas are the areas that are more weather, more rain more precipitation is occurring. Okay, that's the map that is getting shown. This is a radar map of the United States. Okay, so if you look at some of these parameters, starting about right here, we got service equals WMS. Okay, we don't necessarily know what that means. Now I'm telling you that means that I'm making a request to a web mapping server, and I want to get a map, and I have a parameter that allows me to get the format that the map's going to be in. In this case, it's going to be a PNG. I can control the transparency. I can control the height and the width. That's important because if I am loading a base map and I'm loading a map to put on top of the base map, they need to match up. They need to be the same because once they're images, they're not really geo-referenced. So I need them to be the exact same area so that they can overlap with each other on the internet. Here is the code for the coordinate system. Okay, and then here's the bounding box of that image that's getting created. So you can look at the URL, and this is just a URL. It's taking me to a website, and at that website, there's nothing but that image. This in Chrome because there it's a little bit. So that's the image. It's see it's it's got a clear background, so it shows up as white on the white screen. But so this is the United States. That's Texas. So we're somewhere around here. And we could, let's see. I don't know enough about this particular website to know, but I'm going to change the coordinate system to another coordinate system I know. It doesn't like that one. But maybe it doesn't know how to convert it into the program on the server needs to know it doesn't have it's not working, but probably because it doesn't know what coordinate system I'm talking about. But if it did know, if it was able to understand that code, it could change that request. And we'll practice doing this more next week. All right. So those parameters provide specific details to make the web map look different. So we could turn different layers on, different layers off, and so on. Now, what we've discussed here is what's called a web service. A web service is something that's running that allows you to make a request to it and get a response back. This exists outside of maps. Okay? That shouldn't come to you as a surprise. This is really how Gmail works. Okay? When I click on an image, a web service is, when I click on an email, okay, a web service is responsible for saying, okay, I'm going to dispatch a request for that email. Send me the contents of that email as a text, and then I'm going to display it on this web page. So all sorts of data can be passed back and forth, and there could be different formats. Okay, we can pass it back and forth as text, which is very common. We can pass it back and forth as an image, which is very common on the internet. We can pass it back and forth in some sort of binary format if both the client and the server are okay with that and can accept that. We usually would just refer to that as sharing a file. Okay? So technically, when you go on to Blackboard and you download this document, you've sent a request to a web service. The service is just waiting for you to request a file. Okay. All right. In some cases, it's actually a program that's waiting for all the input parameters, and in some cases, with tiled maps, it's actually a tile. Okay. Here's has anybody here used OpenStreetMaps before? Okay, you. Okay, so OpenStreetMaps is a free-to-use, free to actually update and change. Like if you notice that your house is wrong, you can change your street in your house. It's kind of like Wikipedia in that way. You can edit the map itself. You can make changes to the map. Obviously, there's some people there controlling what's going on, but there's a much larger body of people that are actually creating, are responsible for symbolizing and showing the map. Now here, if I go to More Tools, Developer Tools, I should be able to see these individual tiles coming through and go to them. So if I go to Open Link in New Tab, there's one of the tiles. So you can see on this map here, it's actually showing multiple tiles. You can even see them as I pan. You can see them updating. It's requesting those new tiles. Okay, so this whole map is just a bunch of PNG files sitting on a server, okay, waiting for me to pan and zoom around, and then it just pushes that tile to the screen, the browser then puts it in the right location. Okay. So on a tiled map service, you'll notice that there's usually a bunch of numbers, and so the PNG files are organized on the server in rows and columns and zoom levels. Okay, so this is zoom level 15, then row and the column that it's in. So as you zoom in, there's more and more rows and columns. As you zoom out, there's less and less. Different tiled services have slightly different formats. They want to keep this fairly standard for it to be able to overlap with other maps. Okay. All right. So just to drive home, if you read this paragraph, okay, you don't have to know what all these other URLs. Okay? What happens is that somebody has modified this web page to be requesting all of these URLs and displaying to you a map that moves around. You don't have to know and to cobble together these funky URLs. In fact, people have built software tools that make it easier to build these type of websites. Okay, and these software tools range from doing almost everything for you. You could create your own web mapping website. You upload some locations, and ESRI sometimes calls these types of things story maps. Okay, we'll walk through the creation of the story map. Okay, that's a totally prepackaged, ready to go web mapping tool. Down to just giving you kind of like the bare bones building blocks so that you can still control turning on and off different layers, but you have to write some code to do so. So you have much more flexibility to design a web map that you want to do anything that your heart desires, all the way up to a web map that's specifically focused, but it does a lot of the work for you. We'll kind of run the gamut. Okay, in a semester we don't have time to teach you every single web technology, but we'll talk through all of those as we go through the course. So we'll get a little bit more into the architecture next week. But web services is what's the fundamental piece that allows all this to happen, is that there's computers out there that are running web services, and these web services can provide maps. They can also provide data. All right. So not all web services provide the same URLs and parameters. You'll learn about some of the most common formats. Specifically, we're going to talk about ones that give us GIS data, because that's what we care about, our mapping data. All right. So I already walked through this this is just showing you how you can look at the URLs. So if I go, for example, we developed some web mapping data here on campus. Hopefully, with the storm, they're working, not working right. So this is one. It's called glmigratory-birds.org, and this is actually running an ArcGIS server. And so the server I just showed you was, I showed you a tiled server, but before that, the server that I showed you was running a WMS server. It's an open standard. So lots of different people can adopt that standard. The advantage is lots of people can adopt that standard. And then even if somebody else is running a different program, they can still see your data. All right, so here is this map. As I zoom in here, I can see the different data that's been requested. So this was the tile that got requested from this. This is an ArcGIS tile server. I'm trying to find if I can see the overlay that got shown on there. What you see is the land cover. Let's just go to console. Yeah, there it is. Open link, a new tab. So this is the this is the map server. Here's the URL to just that. That's the image that was shown on that map. Okay, and I could change. Let's see if there's any. Well, there's nothing in that. That's the request that came back based on these inputs. I could change the spatial reference. I could change the extent and whatnot, and I get back a slightly different map. Okay. But we'll go into a little bit more detail on that next week, and we'll actually experiment with utilizing different web maps and change the parameters. Great. Okay. So that's how the developer tool will be valuable to you later in the course. Chrome, Firefox, whatever one you want to use has a developer tool. I really don't like Internet Explorer's developer tool. You can use it if you want to, but it always makes you refresh the page. It doesn't show you what's already happened. If you didn't, like, let's say you went to a web page and you open up the developer tools, there's nothing there. Okay, there's no history. But if you open them up after you loaded the page in Chrome or Firefox, it shows it to you. Also, Internet Explorer still runs dynamic web pages slower, and that's not a fact that's in dispute. So it's not like some sort of hate for Microsoft. I don't hate Microsoft, but Internet Explorer isn't the best web browser for interactive mapping or interactive at any sort of interactive web page development. I'm sure they're getting better, but right now that's the way I feel about it. Okay, so that's that section. The second thing that I want to talk about is free and open source software. And I'll let you read through this a little bit more because you're gonna watch a whole video on it, so you don't need me and the video going through here. And I've already kind of talked about it. This course isn't all about free and open source software. Okay, that is something that we're hitting on big at the beginning of today's lecture. And like I said, the reason for that is that in web mapping, there is a lot of really good, in my opinion, free and open source software out there. Okay, free and open source software means that it's free and that it's open source. Open source means that you can go in and actually change and modify the code if you wanted to, and then redeploy it. Now, a lot of you might be asking or saying, I'm never going to do that. And to be honest, when I use open source software, I rarely make changes to the code. I have before, but I rarely make changes to the code. So why is that so cool that you can change the code? Well, it does allow you to have that flexibility, and that is nice to always have that. But another thing that it allows is that it allows you to take your broken piece of software, the stuff that you want to change, and seek out a wide range of people that can fix this problem. If you want your software customized and it's ArcGIS software or commercial software package, there's only one person to take that complaint to, or one entity to take that complaint to. And so there are some advantages and disadvantages to free and open source software, and that's really what the homework assignment is about, is identifying those advantages and disadvantages. But there is a lot of good software out there. Here we go through the difference between the word free. Okay, we know that free has several different meanings in the English language. Free can mean that it's not restricted on how you use it. Free can also mean that it doesn't cost anything. Okay? So sometimes you'll hear people make this distinction by saying this is free as in speech, meaning that it's free to use how you like. And then free as in beer means that it's free as in it doesn't cost money. No, beer isn't usually free, but that's what they mean when they say free as in beer. All right. Okay. All right. Yeah. You'll actually get a lot of this as you go through the video. So we'll leave this. I said we'd only be in here for about 10 more minutes, so I'm going to skip down here. Here's a good summary on some of the benefits of FOSS, and the video actually goes through this. Okay. So obviously the software costs less. That's one big benefit. And then I already discussed this, the second one here. You get more flexibility with the software. You can modify the software yourself. It's easier to do. You do have to have a programmer with skills to do it. Okay. And let's see, security and ethics. You know, sometimes people like the fact that it's open source. One thing that I really like about working with open source software is that it's actually a really big learning tool because it's so collaborative. So this guy is working on a project, this guy's working on a project. They're similar projects. They're working on them individually, but oftentimes they merge them together. They breed this sense of openness. Okay, let's make our software work with other people's software, and that's what's really one of the things that's really great about open source, free and open source software. One of the issues here is that that people can actually make pretty valid arguments that open source software is not as usable. The usability of the software isn't as good, and that's an opinion, but in some cases that's a valid opinion. Oftentimes the front end of the software is the least developed portion of the software. The underneath, the nuts and bolts, the thing that's actually making the software perform really fast and really well, are what gets developed first in the open source world. And these are generalizations, not always true, but that is often the case. And so you'll find that it's not always as user friendly. And one of the advantages to server-side software is that that's actually oftentimes the thing that it doesn't matter if it's developed as well. Okay. It's the server-side software, and it's the stuff on the front end that the user sees is what needs to change. But that presents a advantage for free and open source software. Sometimes open source software isn't documented as well. But that's true for proprietary software as well. But that's one of the arguments against open source software. Support availability. This is one of the big differences. Open source software costs you nothing to get, but oftentimes you have to pay experts, professionals, to figure out how to use the software. Commercial software is oftentimes the opposite. You pay a large fee up front, but then the support is usually built into that fee. So that's something. Okay, so here's some contested points. Some people will say, well, there's more features in open source software versus commercial software, or vice versa. And actually, I think that Paul Ramsey in the talk that you're going to watch makes a pretty good argument as to well, not an argument, but he explains the differences. Sometimes you'll get very obscure, cool features in open source software because somebody wanted it, so they developed the code and they put it in. Whereas you won't get something that you totally would expect. It's a fairly standard feature in open source software because nobody's spent that time. So sometimes it's not targeted for the mass; it's targeted for an individual niche better. And so it depends on how you do that. Quality and technical superiority. There can be bugs in open source software, but again, that's contested. All right, so let's talk about open source software in the GIS system. Here's some open source software packages. Okay, let's skip down here to free and open source software in web mapping. Free and open source software in GIS actually started a long time ago. It started back with desktop GIS. And the very first one that was created, and we mentioned this because it's the first one that was created, was called GRASS. It was developed by the government, actually. U.S. Army Corps of Engineers developed GRASS. I don't use GRASS a whole lot, to be honest, but it is one of the first desktop software GIS software packages out there. It's not a web mapping software package, but you'll find out that you need to have something to kind of organize your data, analyze your data, create your data before you publish it. So you're going to have a web mapping product. You're going to need a desktop product to create a web map. You can't really get around that. I use, when I turn to an open source software packages for desktop GIS, I use QGIS. To be honest, I probably still use ArcGIS as my desktop software package 80% of the time. Okay, I have QGIS loaded, and we'll talk about it in this class. But ArcGIS is a very good desktop software package, so I use ArcGIS. QGIS is probably the leading open source software package, though. So you can go here to this website and download QGIS if you wanted to. I believe it's installed on most of the machines. They might be an older version. I'll check on that before we start using it. All right. Oh, and by the way, for those of you who want, this is a little side note, but all of you that want a copy of the latest version of ArcGIS to run on your personal computers, send me an email, and I'll send you an activation code and some instructions. Okay? And you know, if you're gonna work on this a lot at home, it might be good to also to download and install QGIS. You have QGIS and ArcGIS. Those are the desktop software packages. Okay, that I would recommend. Although GRASS is another option. All right. Okay. As far as map servers, what we call map servers are these programs that are waiting for maps to be generated. They're for creating dynamic maps on the internet. Okay. You can often specify different projections, different layers that you want turned on and off. That's what a map server is. Okay. Probably the seminal, the thing that started map service, open source map server was actually just called map server. It's still called map server today. Originally it was called the Minnesota map server, but now they just dropped that. It's called map server. There's the URL for map server. QGIS actually has their own map server. You can take QGIS and turn it into a map server. It's a program that's waiting. And all it does is it uses the same code that QGIS already uses for making maps, and it turns them into images, serves them out on the internet. That's one thing that we'll actually do in this class, is create a QGIS map server. GeoServer is a more modern map server that's written in Java programming language. So if you wanted to modify it, you have to know Java. That's probably, I hate to point as one of these as the leaders, but that's one of the more common open source map servers. I don't know for sure which one is the biggest one, but that one is very common. Then there's all sorts of kind of bare bones open source software packages for serving maps. Like if you want it a very simple one that only does a few things, there's a bunch of people. You can go onto a site called GitHub. That's a place to share your code. There's all sorts of people that have written very simple map servers. If you're not concerned with having a big graphical user interface, probably not going to get into a lot of those because those involve some tweaking and knowing code, but they do exist. There are also free and open source packages for creating tiles to serve up on the internet. TileMill is one of them. Okay, TileMill is actually created by a company called Mapbox, and Mapbox is a for-profit company, but they created TileMill, and TileMill itself is open source. All right, now a lot of these packages actually use, a lot of these free and open source packages actually use a library called Mapnik in their core. A MapNIC, all it does is allow you to, it basically does the same thing as ArcMap, but all in code. You have to specify, the map you want drawn, and it draws it. It's a program that creates maps, but it's not an internet server. Okay, so what some people have done is when they create their internet server, they build it on MapNIC. MapNIC creates maps, and an internet server waits for the parameters. It feeds them to MapNIC, creates the map, and it turns it back to the user. All right, we'll get into specifics of the architecture again later. All right, MapNIC, for example, could be used to create a desktop GIS or an internet map service. It's a tool for creating maps, not a tool for internet map services. Okay, now, oftentimes you'll need to store your data somewhere. When lots of people are using your data, oftentimes it becomes more efficient to store your data in what we call a database rather than storing your data as a bunch of files. And in some cases, there are actually databases that have GIS functionality right inside the database. For example, first of all, has everybody taken like an introductory GIS course or the equivalent? Like when I say I'm going to take two layers and do an intersect. That makes sense? Everybody? That makes sense to everybody? Okay. So if I have a database that's spatially enabled, and there's actually a course, some of you may have already taken it, so I may be redundant here, but not everybody's taken it. If I have a database that's spatially enabled, and I have two different layers, I can actually say, okay, I want a new layer. Just show me a new layer that's the intersection of those two layers. So it basically shows me only the areas where both of those layers overlap. I can just ask the database that question. I don't even have to change my data. It does that intersection for me. And we are going to get into a little bit of that towards the end of the course. All right, so there are software packages for doing that. One of those is called PostGIS. It's probably the most common one. There's another open source software package that's roughly equivalent to the ArcGIS concept of a file geodatabase. Everybody know what I'm talking about? I say file geodatabase. File geodatabase can contain multiple layers, right? It's kind of like a folder, but it's a single entity, and it can contain lots of different GIS data layers. Well, Spatial Light does that for you in the open source world. It's actually a single file that contains multiple. It can contain multiple layers. Okay. All right. Another thing that we're going to talk about in this course, kind of talking about the things we're going to talk about in this course, is what we call, it's like really bumpy. It's like the lightning is causing the screen to bounce. Or maybe that's just anyway. It's called an application programming interface. An application programming interface for web mapping is what allows you to create a slippery map, add layers, all using JavaScript. So I can turn layers on and off. I can do queries. We're going to do that in that course. And the open source versions of these are called OpenLayers and Leaflet. Those are probably the two very most common. Modest Maps is another one. Polymaps is another one. I didn't include the links for Polymaps. Those are other versions, but open source and Leaflet are definitely the leaders in the open source world. In the ArcGIS world, it's called ArcGIS for JavaScript, I think. I think they're changing everything to 4 whatever. Oh, by the way, ArcGIS is equivalent to a GIS database. It's called ArcSDE. And ArcSDE is a program that sits on top of your database, whatever that is. Okay, we'll get into that when we talk later. All right, now we've talked a little bit about open source software. There's also some people say open specifications, and some people say open standards. Okay, those mean roughly the same thing. There's also those, and then there's open data. Okay, open data means that the data is freely available. And that's happening more and more. governments and even private sector places are putting their data to be available online, so you can modify it. Okay, there are web services out there for finding an address, for example. That wasn't around 10 years ago. Okay, there's a web service, and they're actually free to use up to a certain point. So you could geocode a bunch of addresses and show them on the internet. Okay, we'll walk through examples of how to do that. In order to do things like that on the internet, you need to specify how that data is going to be passed back and forth. Okay, that's what we mean by open standards and open specifications. So like anybody know what a KML is? What does KML stand for? Anybody know? Okay. Some sort of markup language. Yeah. Exactly. Okay. Google, like it usually does, actually bought out a company called Keyhole, and so Google Maps, Google Earth used a standard. It's a text file that looks a lot like an HTML file, but it stands for Keyhole Markup Language, and that's now an open standard. Okay, Google set that up. The shapefile itself is technically an open standard now. ESRI published how to make your own shapefile. So that's why so many software packages use shapefiles now, because it's out there, and they say if you want to make a shapefile, it has to look. The file itself has to look like this. Shapefile is still not a file you can open up and read with your eyes. It's still a binary file. It's still storing a bunch of ones and zeros. But they've specified how to store all that information in the files, so that different people can create their own libraries for reading and writing shape files. Everything can be specified. So everything from the format of the request itself that's going to a map service, that can be specified, and that standard can be published. Okay, so one reason why we might call it a standard is that it's been agreed upon by a large body. A specification can be open, but it's maybe just agreed upon by a commercial entity. So ArcGIS has shared how they request and share data, and so has the open source world. All right, open data formats. That's like KML I mentioned. GeoJSON is another open source or an open data format. Technically, a shapefile I mentioned already. That is that's an open, openly documented. It's open. Okay, although it was created by a commercial entity, it's open now. In contrast, the file geodatabase is not openly shared. So you won't find a lot of other programs outside of ArcGIS that allow a file geodatabase to be created. Okay. Now you can actually pay ESRI, and they'll give you a license to distribute code that they've created that's compiled, so people can't read the code, but they'll allow you to write a program that reads the file geodatabase. But you have to pay ESRI for that privilege, and they don't actually show you the code at the end. And again, I'm not trying to bag on ESRI. I'm just opening up. There's these two different worlds, and they really do mesh really well in this web mapping. And hopefully by the end of the course, you'll see that you can actually use what's called a hybrid approach. So some of your software can be open source, and some of it can be proprietary, and they can get along pretty well, especially in this web mapping world. All right. One of the big specifications that we've actually already used without you knowing it at this point is the WMS specification. Okay, a specification means that I'm specifying how a particular request has to come in and what the response will look like to that request. So the WMS standard is the free and open source standard for that. So they've set up that. ArcGIS also has their standard, and it's open. You can actually see that if you just went to the. I think it's actually linked at most This is one of the ArcGIS servers that we have set up to support some of the projects that I work on. So if you hit the API reference up here, this is the standard. This is the standard of how the request needs to come in. So for example, if I want to make a request to a map service, this is saying how the map service needs to be requested. Okay, HTTP, the name of the server, the service name / map server. If I went back to this one, it looks like that. So that's the link to a map server, the California map server. And these are all the layers in that map server. If I want to look at this, I can just hit export map, and it'll show me that. Of course, none of the layers are turned on. So let's see if I show. Always doing live demos is always hard. The layers are all off by default on that particular map, so that's why they don't show up. But just trying to get it to show up there. But that's this is an example of a URL, and it's an example of an open specification. So they've specified it. Now they're the ones that have specified it, though. It's not open in the sense that the public isn't free to comment and change it like they would be with a web map service. And they do change. There's different versions that get released. So the web map service version 1, WMS version 1 is different than WMS version 1.1. And they're only slight differences, but they do change over time. Okay. So this is what I was talking about. In a document called the GeoServices REST specification, that's what I just showed you. They've documented the form of communication. Okay. So it's an example of a specification that's involuntarily made open by a proprietary software vendor. And the nice thing about that is that maybe this doesn't mean a whole lot to you yet, but I could use an ArcGIS map server because the specification is open. I could use an ArcGIS map server and request that from a open source mapping tool, if that open source mapping tool decided to adopt ESRI standard, which a lot of them have, or at least adopt that as one of their options. Okay, open data means that data is open. I'm not going to go through that. I'm going way past what I told you. Of course, this is still within the time period that the course should allow, but not much. Okay, we got about 20 minutes, but I promised I wouldn't go too much further. So I'll let you look at this over. This will probably mean more to you anyway as you go through the course, but this shows some of the open source software versions that do roughly the same equivalent as the ESRI version of those software packages. Okay, so let's get on to what you're going to do for your assignment. So for your assignment, let's go back to, got so many tabs open. Let's go back here. If you open up the assignment, you'll get that. It's called assignment 1. And you can read through the assignment. You'll watch a video. The video lasts about 45 minutes. If you want to watch it right now, you can. But we're not gonna have a formal lab today where we sit around, work on the computer. So you can do this on your own time. You could leave, come back. But to be clear, you do have to finish this assignment. Most assignments will be that you get 2 weeks, but you have to finish this assignment before we meet next time for class. And the reason for that is that I'm using it to take roll. Okay? All right. Now, if you really have a problem where you can't complete this before next Tuesday, then send me an email and say, hey, come up with a good excuse. I couldn't do it, but I don't think that you should be able to watch a 45-minute video before next Tuesday. But if you can't, send me an email, give me your excuse, and then say, hey, I'll post it as soon as I can. But please count me present. So I need to enter that stuff before we meet next time. So I'll probably do it Tuesday at noon or something. I'll be entering all the people that were present and not present. Okay. All right. So watch the video, read these 3 sites. They're all pretty short. This is really short. These are pretty short. Read those over. And then what you're going to do here is you're going to make a post on the lesson 1 assignment forum. Go to that. That's in here. If you go to discussions and lesson 1 assignment forum, if you click on that, then you can create a thread and post. All the instructions are also right here. I just copied and pasted them right there. Okay. So you're gonna write a little thing, and I don't want it to be huge. So, but one of the things that you need to pay attention to is that for this assignment, once you post, you're not going to be able to change your post. The reason why I'm doing this is that I don't want the first person to post and the second person to say, well, I can write a better response, and basically write what they wrote, but then write more. You know what I'm saying? So you aren't going to actually be able to see what anybody else posted until after you post. Now, if you want to, I'm still not opposed to you guys discussing ideas, okay? And seeing somebody's actual written response, we'll have to wait. But let's say you meet in the hallway. I don't think it's cheating to say, hey, what are you going to write? And what are you going to write? And kind of floating around ideas. That's fine. But I don't want exactly what somebody else has written plus some additional stuff, okay? So once you post, you're not going to be able to edit your post. So don't post until you're ready. Write it up, copy and paste it in there, okay? Also, you won't be able to see other people's posts until you post. So it's just designed like that. It's one option Blackboard has, so that you can post assignments in there and that they can be available to others to see, okay? All right, so which of Ramsey's observations, Ramsey's the guy talking in the video, about, he basically contrasts free and open source software, and to be honest, he is talking from a free and open source software is better standpoint. That's his, he runs a company that supports free and open source software. But, so which observations have you observed in your own home or in your workplace? This doesn't have to be GIS related. If you don't do a whole lot of GIS stuff, but you still use a computer, you can have an opinion on this, okay? Or if you don't think Ramsey's observations are legitimate, justify why. It also might help to go through the reading again before we answer this question. Okay? There's not a single correct answer. I just want you to think about this topic, right? Also, answer this question. After studying this lesson, would you advocate the use of pure FOSS approach for your GIS work? Or are there certain elements of proprietary software that you retain as part of a hybrid approach? And kind of make an argument as to why you do what you said you would do. Okay? I've already told you that I think that this is a good market for a good area for using both. But you can have a different opinion. You can say, hey, I'm sticking with ArcGIS all the way because I'll be able to call up and they'll be able to help me through any problem I have. Or you can say, I'm going all FOSS because it's cheap and I can figure things out. Okay? So you can have whatever opinion you want. You need to justify it. You can make 2 posts addressing these individually, or you can do it as one. Obviously, you'll start to see everybody else's posts when you make one. So I guess you can get around it slightly. Post one, and then you can see, but you won't be able to change your answer to the first question. Okay, you'll be graded on the depth of your argument you put forward in your response. I'm not going to grade super hard on this first assignment particularly, but I do want you to put some thought into it and answer the questions. Okay, you won't be graded on your opinion. Okay, your opinion is your opinion. You won't be, if you say that ArcGIS is the best thing since sliced bread, even if that's not my opinion, and I've already said that I do like ArcGIS, but anyway. All right. So, anybody have any? Oh, to receive full credit, you also have to write at least one response to another student's post. I kind of debated whether or not I should do this because I don't want people to yell at each other, but I decided to throw it in there. So write a response to another person's post. Most of your grade will come from this. Okay? So So this is a response though that you need to do. And let's see here. All right. So continue to think of this. This will kind of form the basis because we're going to use free and open source software and ArcGIS software, so you get to see both of them in the course, and hopefully it'll kind of form the foundation for you'll kind of see why I did it later as you start to work through different software packages. All right, anybody have any questions? All right, so yeah, we took. Normally we meet for a little over 2 hours. We didn't quite get there, but it is the first day. We got pretty close, right? So what time is it? It's almost 2 o'clock, right? Or almost 3 o'clock. Yeah. Oh, 20 minutes till. Okay. So if anybody have any questions, email me, post them on the forum, call me. I will be in my office tomorrow. Do a faculty meeting later in the day. However you want to get a hold of me. All right? And we'll meet again in just a few days on Tuesday. All right?